Now that we are experts on multiplying and dividing rational expressions, we are going to have to move on to adding and subtracting them. So just again, rationals are fractions, really, with polynomials in the numerator and the denominator. When we add and subtract fractions, we need common denominators. We need the same denominators. This is different from when we are multiplying and dividing, because when we are multiplying and dividing, the denominators do not matter. With addition and subtraction, it makes a huge difference if we do not have the same denominators. We have to make sure we get them. So just a review of finding common denominators in order to add or subtract fractions. I know we did this at the very beginning of the year, but it's been a little bit since then. Oh dear, here comes my cat. All right, he is not in the frame, but he might be here in a second. So as we're going through this, you're going to have the option of pausing this video whenever you like and moving over to the Delta Math assignment. So for each of the problems, I have referenced which Delta Math problem it is like. So for this one, this is just like the Delta Math problem number 1. So if you have forgotten how to add or subtract fractions, when we are adding or subtracting fractions, we need to find a common denominator. We need to make sure that we multiply both the numerator and the denominator of each fraction by the number they need in order to get to the least common denominator. So between 7 and 9, if we're ever not sure with what our least common denominator must be, we can just multiply the denominators and we'll get to where we need to go. It might not be the least common denominator, but it will certainly be a common denominator. So 7 times 9 is 63. So foolproof way of doing this is by multiplying the top and bottom of this by the denominator of that. So we can do 9 over 9 times negative 3 over 7. And then same idea over here. We can multiply the top and the bottom of this by the denominator of that. So 5 over 9 times 7 over 7. And then we go ahead and we simplify this. So 9 times negative 3 is negative 27. 9 times 7 is 63, as we said. 5 times 7 is 35. And then over 63 again. When we add or subtract the numerators, then we add or subtract the numerators while leaving the denominators the same. Unless, of course, the fraction can be simplified after we add or subtract. We don't simplify first because that literally undoes all of our previous work. So you can see here, okay, well, negative 27 and 63, those are both divisible by 9. But if you try to simplify that, then we're back where we started. So don't simplify until after. But when we add or subtract fractions, once we have a common denominator, the denominator stays the same. So this is going to be still over 63. And now we just subtract these. So negative 7 minus 35, that's like, or negative 27 rather. That's negative 27 plus a negative 35, so we can just basically add these and slap a negative on the end. So by my mental calculations, we get negative 62 over 63, and I don't think that can simplify at all, so that would just be our answer. I know you probably still remember how to simplify, or how to add or subtract fractions, but I wanted to make sure we got a little bit of review out of the way before we jumped into this. So another bit of review that we need to do is talking about how we subtract polynomials. When we subtract polynomials, we have to distribute the negative from the subtraction to all the terms in the second polynomial. So this one here is like problem number 2. I know we know how to add and subtract polynomials, but I wanted to make sure we got this review in so that I could clarify stuff before we moved on. So we have the polynomial negative 5x plus 2, and we're subtracting the polynomial negative 4x squared minus 6. So we have to make sure that we distribute that negative from the subtraction to both things. So now we have negative 5x plus 2. Once we distribute that negative, we can ignore the parentheses. We don't need them anymore. So negative 4x squared becomes positive 4x squared. Negative 6 becomes positive 6. And then we just combine like terms as applicable. In this case, we can combine just the 2 and the 6, it looks like. So we rewrite it. You don't have to write it in standard form with the descending order of exponents, but I prefer to write it that way. So it looks like our final answer here is 4x squared minus 5x plus 8. Because, of course, negative 5x and positive 4x squared are not like terms, so just watch out for that. All right. So when we are subtracting rational expressions, adding or subtracting rational expressions, we kind of combine these strategies. We have to make sure we have a common denominator, and we have to make sure that we distribute the negative if we are subtracting. So one thing we can do is we can initially put parentheses around these numerators, and then we can write it all over the same denominator. You can kind of do these steps whichever way you like, whether you want to distribute the negative first and then put it over one denominator, or put it over one denominator first and then distribute the negative. That's up to you, as long as you get both steps in. So for right now, I am just writing it over the same denominator. And then I'm going to distribute that negative. Looks like my marker's dying a little bit, but hopefully this is still readable. So now we have 6x minus 7 plus 7x plus 9, all of that over 4. And we combine our like terms. So 6x and 7x, negative 7, positive 9. 6x plus 7x is 13x. Negative 7 plus 9 is plus 2. All of that over 4. Ooh, that is a little blurry, huh? If you prefer to write this as two different fractions, you can. You would just split up where it is at the plus or minus and write it both over the same denominator. But you do not have to do that. You could then, of course, simplify that 2 over 4. But most of the time, I'm probably just going to leave it like this. That is fine. So either one of these would be our final answer. And I think I'm going to switch markers before we go on to the next page. So this one, again, is going to be like number 3 on the practice. So if you are trying to go through number 3 and you get a little stuck, you can come back and look at this. So regular fractions are fine. We just need to multiply the bottoms together to find our common denominator. But to determine the least common denominator, or LCD, between two or more rational expressions, first we have to have the denominators fully factored. I keep saying that before we do anything with rationals, we want to factor everything that we can. This is particularly true with addition and subtraction, because then we can easily see what we need to do. Because once we have it factored, we can determine what factor or factors one expression has in the denominator that the other is missing. So this one here is like problems 4 and 5. We have 1 over x plus 4 plus 7 over x. Now remember that x plus something, or x minus something, is itself a factor. We cannot separate them. So I'm going to go ahead and draw parentheses around this x plus 4. You don't have to do that, but it definitely helps. I try to do that as much as I can, as much as I remember to. Because now we can see that x plus 4 is a factor and x is a factor. And so this one has the x plus 4 but is missing the x. This one has the x, but is missing the x plus 4. So just like with numerical ones, just like with numerical fractions, we multiply both numerator and denominator by the factor the expression needs to get to the least common denominator. So our least common denominator here is going to be x times x plus 4. Those are the factors that we need. So we need to multiply this first one by x over x. So 1 over x plus 4 multiplied by x over x. And then we need to multiply the second one, 7 over x, by x plus 4 over x plus 4. It's easy to look at this initially and think, oh, we just need to add 4 to this one because this one has x plus 4. But that is not the case because x plus 4 is one singular factor, one singular unit. We can't break it up. It is distinct from plain x. Even though it looks like you just need to do a little bit with it, we actually have to do a whole bunch more with it than it looks like. So now we go ahead and we do this multiplication. X times 1 is just x over, I'm going to leave it as x times x plus 4. You can distribute it if you want to, but there's no need to add an extra step. I will, however, distribute in the numerator because that will let me be able to add like terms later. So 7 times x is 7x. 7 times 4 is 24. I'm running out of room here a little bit, but you get the idea. Over x times x plus 4. So now that we have done that multiplication, we've gotten our common denominators, we put it together. So we had x over x times x plus 4 plus 7x plus 24 over x times x plus 4. And again, just like with numerical fractions, make sure that you aren't simplifying anything until after you have done the operation you need to do. So we can write this as one big fraction over x times x plus 4, and we combine our like terms. So x plus 7x gets us 8x, and then the 24 has nothing to add to it, so it's just 8x plus 24. And then if we wanted to, we could take out that x and get, I believe, x plus 3. But that doesn't look like that'll get us really anywhere for simplification purposes, so you can leave it either way, whether this is your final answer or this, because we can't simplify that at all. Either one will work. So again, this one is like the problems 4 and 5. So yeah, we just simplify and then add or subtract our numerators as applicable. We've got one more down here. This is like problem number 6. We've got x over x minus 3 plus 5x plus 1 over x plus 8. So again, I'm going to put these in parentheses down here and up here, just so we can really see that x minus 3 is different from x plus 8. We can't just subtract 3 or add 8. We have to do something different. We have to multiply these together properly. So this has the x minus 3, but it does not have the x minus 8, or x plus 8. So we have to multiply this one top and bottom by x plus 8 over x plus 8. And then this one has the x plus 8, but does not have the x minus 3. So it needs to be multiplied by x minus 3 over x minus 3. And now, again, I'm not going to multiply this out in the denominator. I don't feel the need for that extra step. I'm just going to leave it as x plus 8, x minus 3. But in the denominator, or in the numerator, sorry, I am going to do that multiplication because I want to be able to combine any like terms that I might end up with. So let's see. X times x, that's x squared. And x times 8 is 8x. So that's our first one. Plus, now this one we do have a binomial times a binomial, so that means we will have to FOIL that. So we multiply our first terms together. 5x times x is 5x squared. Then our outer terms, 5x times negative 3 is negative 15x. Our inner terms, 1 times x is just x. And our last terms, 1 times negative 3 is negative 3. Now, we can combine any like terms that we have in this one first, and then put them all over one big fraction, or we can put it all over one big fraction first, and then combine any like terms. I think I'm going to combine like terms amongst the fractions first, and then put them together, but if you can keep all your terms straight, you can do it whichever way you prefer. Just, of course, be careful that you don't lose anything. So the 5x squared doesn't have any friends, that just stays. Negative 15x plus x will become negative 14x, and then the negative 3 is still fine. Also, be careful, do not cancel these negative 3's. They are not the same, because this is x minus 3, and this is part of 5x squared minus 14x minus 3. Don't fall into that trap. But now, finally, we can put everything over one denominator. So x squared plus 8x plus 5x squared minus 14x minus 3 all over x plus 8 times x minus 3. And again, we can combine any like terms that we might have. Looks like we've got x squared and 5x squared, positive 8x and negative 14x, and then the negative 3 again doesn't have any friends. So x squared and 5x squared becomes 6x squared. 8x and negative 14x becomes negative 6x. And then the minus 3 hanging out on the end. X plus 8, x minus 3. And then if we wanted to see if this would simplify at all, we could. This looks like it has a greatest common factor of 3. 2x squared minus 2x minus 1. I don't think there's any combination of factoring this that's going to get us x plus 8 or x minus 3, so I think we'll just leave it like that. So you can leave it like this if you prefer, or try to factor it out more. That's up to you. And again, this one is like number 6. Let's see, what time are we at? Okay. We've got 2 more that we can do. Just a couple more kinds of these problems. So number 7 here is something like this. 3 over x squared minus 25 minus 2 over x plus 5. Now again, we want to factor anything that can be factored first. So this is a difference of perfect squares. X squared minus 25 factors into x plus 5 and x minus 5. So now we can look at the denominators and see what the difference is. So this one has x plus 5 and x minus 5. This one only has x plus 5. So that means that we're going to have to multiply this by x minus 5. So this will stay 3 over x plus 5 times x minus 5. But this one we have to multiply by x minus 5 over x minus 5. So we can distribute 2 times x is 2x, 2 times negative 5 is negative 10, and then this can stay x plus 5 times x minus 5, or you can multiply it back out and get x squared minus 25 if you prefer. I like to keep things in their factored form because I like doing less work if I have that option. So I'm just going to leave it in the factored form down here. But now we can almost just write this as one big thing. Be careful because this is subtraction. So this is going to be 3 minus the polynomial 2x minus 10 over x plus 5 times x minus 5. So we have to make sure we distribute that negative. That's a really easy step to miss. Don't be the person that misses it. So 3 minus 2x plus 10 over x plus 5, x minus 5. And then we combine like terms, which it looks like is 3 and 10. So we have negative 2x plus 13 over x plus 5 times x minus 5. And that would be our final answer. So this one is like number 7. It's going to be something where it's a difference of perfect squares in the bottom, with the other one having a denominator of one of the factors of that difference of perfect squares. And then the last kind of problem we're going to look at today is something like this. 5x plus 1 over x minus 6 minus x over x squared minus 10x plus 24. So what this is going to be is we have to make sure that we factor this. So this is a trinomial. That means we multiply to the positive 24, add to negative 10. So multiplying to a positive number, that means both of our signs have to be the same. And adding to a negative number, okay, then we must have negatives. So to multiply to 24, let's see. I think that's going to be 6 and 4. Those would add to 10. Yep, okay, cool. So we can replace that with x minus 6 times x minus 4. And then we can look at our two what's the word I want? Expressions, that's the one. We can look at our two expressions here and see what they're missing in order to have a common denominator. This has x minus 6 and x minus 4. This one only has x minus 6, so we're going to need to multiply that one by x minus 4 as well. So 5x plus 1 over x minus 6 times x minus 4 over x minus 4 minus x over x minus 6, x minus 4. Now again, you can multiply this out, you can FOIL this out, but I wouldn't bother in the bottom. I'm just going to leave it as x minus 6 and x minus 4 in the bottom. In the top, though, we do want to FOIL that out so we can see if there are any like terms that we can subtract that x from. So FOIL f is first, multiply our first terms, 5x times x is 5x squared. Then O stands for outer, so 5x times negative 4 is negative 20x. I stands for inner, 1 times x is just x. And L stands for last. 1 times negative 4 gets us negative 4. And then minus x over x minus 6 times x minus 4. And we combine any like terms that we have. Over here it's negative 20x plus x. So that one simplifies to 5x squared minus 19x minus 4 over x minus 6 times x minus 4. All of that subtracted by x over x minus 6 times x minus 4. Now the last thing we have to do is combine these. So we've got 5x squared minus 19x minus 4 minus x, all of that over x minus 6 times x minus 4. And the negative 19x and the negative x are like terms, so that will get us to that. And we're done. So problem number 8 in the practice is something like this, where we have to factor a trinomial in the one denominator, and then the other one's denominator is one of the factors of that trinomial, and we have to multiply it by the other one.